All right, good evening, everyone. Dr. Vaughn, and again, we're live. This is during our synchronous session time. We have one student here with us. We're going to take a look at Chapter 4 homework problems. These are the ones due tomorrow, Thursday, and we're starting a new topic. So we're moving into paired or bivariate data. There's two scores, and they're linked together, and so each one of these, pairs can be plotted as a specific point on an X and a Y. So take one of them as the explanatory variable, one of them as the response, and then each dot on this kind of a picture represents one of those pairs. If I blow this up a little bit, you can see it a little clearer with the scales that are involved. This kind of a picture is called a scatter plot. And we talked about this, I think, in one of the previous chapters when we're looking at types of graphs. Scatter plot is a bivariate paired data, each dot representing one pair of numbers, one from the explanatory and one from the response, or one from the X and one for the Y. In this section, what we're looking at is a measure called the correlation. And the correlation is how linear are these things. And so we're trying to fit what's called the line of best fit, the regression line, to the dots. And so in this particular case, the dots have this upward curving kind of pattern. It looks almost exponential to me. In other words, they were straight, maybe between 0 and 4, but then they shoot off. So it's either two different lines or it's some kind of a curve to it. So the data points don't really appear to be linear. And therefore, the correlation would be, we'd call it fairly weak. It is positive, because as you move to the right, the data points tend to move up instead of down. As you move to the right, they tend to move up instead of down. But it's not going to be a linear relationship. It's not really the right kind of model to build for these data because they have this curving to them. And it's not just a little curving, it's actually pretty dramatic, right? So I would select as my choice as a response to this one, the data points don't really appear to have a linear relationship. It's not because they lie mainly in a straight line. They don't lie in a straight line because they do not lie in a straight line. So I think the answer here is going to be B. Oh, looks like there's another part to it. Let's continue to see the next part. If it's linear, do the variables have a positive or negative association? Well, we answered it's not linear in the first part. So I'm just going to answer the same thing. It's not linear in the second part. Here's another some examples of some correlations, scatter plots. You can see this one has some dots that don't really fit the pattern. Those are called outliers. This one, they're all packed pretty closely in towards that line. And this one, there's a general trend, but it tends to be a little bit, fuzzier. So what we're going to do is use that kind of just eyeball estimation. We're not calculating anything to do a multiple choice here. This one is the tightest in towards a straight line. So it should have the largest positive value. And they're always between -1 and 1. So this one, number 2, I'd say corresponds to B because it's the largest positive R value, which is this value of the correlation coefficient. So I'd say B is going to be 2. A, I have that general pattern. I have a little bit of an outlier, but I think it's still a pretty good association with, maybe a couple of exceptions. I'm going to select that A corresponds to the R value of 0.787. So C is the R value of 0.787 corresponds to diagram number 1. And finally, this R value of 0.523, that's middle of the road, which is kind of this one, I think, where they're spread out. An argument could be made between these two, and maybe this is a chance where I'm going to get one of these wrong. This one is the one that really bothers me, whereas this one, they tend to kind of vary on either side. I'm going to try it. If I get them wrong, then 1 and 3 are just the ones that would be switched. 2, I'm very confident about that one. Yeah, so that's what I was suspecting, is that this dot over here has a much bigger impact. if I took that away, they're actually pretty close to being like this. And so that dot is having a much bigger impact, and it's leading to this smaller, whereas this one is closer to this one. They're actually not as far away. So I'm just going to switch my answers and just go 1, 2, 3. Right. Again, you can kind of practice this after a while. You'll get several opportunities to estimate the correlation coefficient, to compute it by hand, and then to determine if there's a linear relationship. One of the things I'm going to show you on this particular problem, and maybe this is the last one that I'll do from this section, is if I have the data set itself, the X's and the Y's, I can open this in StatCrunch or in Excel, and let's try StatCrunch. And then I don't have to actually guess, and I don't have to, by hand, compute the correlation coefficient, because I can go to the data and I can compute different sorts of things. So let's look at the stat. I'm looking for something related to correlation. Okay, summary stats, correlation. Okay, so the two things that I want to correlate is X and Y. So I'll put those both over here. I don't need a p-value. I don't need a duplicate. Sort rows by. I don't really need to do anything like that. Let's just compute. And what you get is the actual correlation value. I know it's very, very small on my screen here, but I'll read it out loud to you, 0.9249. And so let's just kind of store that away for a minute. That's the correlation. They also want to draw a scatter plot diagram. So instead of doing that by hand, I can go to graph and a scatter plot diagram. And the X variable is going to be the X. And the Y variable is going to be the Y. And I can pretty much leave everything else alone. I don't have to set a lot of these. There's a whole bunch of options here, but just say compute. And here's my scatter plot diagram. So now I'm going to match this up with what I'm seeing over the screen. In particular, I have one dot over here, one dot up here, and then I have two dots, and then one. So this dot is higher than that one. So that's not the right picture. Okay, this one looks like it might be okay. This one's going downward, and this one's going downward. So it's got to be B. Right? So again, use a process of elimination. And now the correlation coefficient rounded to 3 decimal places. So now I'm going to take this number, 0.9249, go to the 4th decimal place in order to round to 0.925. So the StatCrunch makes it super easy. And finally, the correlation coefficient is positive, and the absolute value of the correlation coefficient, I think they want R is, let's see, is it greater than, let's look at the critical values. Okay, so N is, we have 1, 2, 3, 4, 5 different data points. So for N is 5, 0.878 is our critical value. And therefore our R is greater than the critical value for this data set. Then let's see what the options is. A positive, because it's sloping from up to right, linear relation exists between X and Y. I just wonder what goes in this box right here. Then the critical value, oh, okay, the absolute value of the correlation, okay, I think they want to type the number here instead of the letter. I'm going to put 0.925. And over here, they want the critical value, which I should have written down off of the table. So let's pull that up again. N equals 5, 1, 2, 3, 4, 5, 0.878. I think they want me to type 0.878 here. All right, let's give it a shot. And that's how you do some of these. Anyway, scatter plot, we looked at a scatter plot, we looked at calculating the correlation coefficient in StatCrunch, and we looked at interpreting some of these results by comparing it to the critical values. For just a moment, let's try one problem from 4.2. So 4.2, we're actually going to graph what's called the least squares regression line on the scatter plot itself. I'll just do this first one. Here's the data points themselves. I'm going to load this up into StatCrunch. Here's my X's and here's my Y's. First, the scatter plot. So again, graph, scatter plot. Okay, X variable is going to be X, Y variable is going to be Y. And now let's see if they actually give us the option to do the regression line on here. Doesn't look like it. I know how to do this in Excel, so let's go ahead and just look at the scatter plot diagram. That'll allow us to answer part A. 2 dots that are horizontal, and then they're kind of dropping. I got 2 dots that are vertical over here. So 2 dots that are horizontal, 2 dots that are vertical, dropping off in between. Could be this one. Let's look at the difference. Looks like the X's. So at X equals 0, Y is 5.8. So looks to me like the 5.8 over here is not until X equals 2. So I think in this case, D is the right choice. Okay, now does there appear to be a linear relationship? Well, they're declining, so even though it's going down, it's a linear relationship. So yeah, I think it's a linear negative relationship. It's not a very big data set, but that's okay. And now we need to find the line of best fit, the least squares regression line. All right, let's see if we can figure out how to do that in StatCrunch. So I'm going to look for regression. A regression, simple linear. The X variable is X, the Y variable is Y. I'm not going to do a hypothesis test. Let's just go ahead and say compute. All right, so here is my regression equation. Again, it's very small. I try to move it onto the video screen in case it was off the screen when you were looking at it. Y equals 6.4439 minus 0.646x. Over here, they put the x first. So I'm going to put the negative 0.646. Negative 0.646. And then the number that's by itself is 6.44. 6.44. That is my model. That's my best fit line. And this I can use to plug in x's in order to predict y values. And it says my answer for slope is correct, but the y-intercept is incorrect. Maybe I typed a digit wrong. Let me take a look at that again. 6.4439. Oh, it wants 3 decimal places, so that would be 6.444. I think that's it. I think I just need an extra 4 there. Yep. Okay, that was it. So we did scatter plots, we did correlation, and now we've done regression. And now you put this line of best fit on top of the graph of D, and you get the graph of C. And we're on to the next question. All right, this has been your video for today. Hope these are helpful, and I'll talk to you again soon.